Hello everyone. Today I'll demonstrate the CPU.hdl implementation. Starting off, let me tell you what are the inputs and the outputs. So first up, we have the input, which is the first input, which is in M, which is a 16-bit input, is the input from the M register. Now, next up we have an instruction register, which is also a 16-bit input, and then we have a reset bit. Same is up with the outputs, which we have one outem, which is again a 16-bit register. Sorry, 16-bit output, and is outputting one 16-bit value to the M register. Then we have write M. Write M is a 1-bit output which determines whether the M register is writing or not. Then we have an address M, which is a 15-bit register, and at last we have the program counters, which tell whether here are the program counters which tell whether the which instructions is being read next. So if we go to our parts, so these are the parts, this whole, and in parts we have this chunk, which is two NOT gates, and these two NOT gates are responsible for the instruction check. So first we'll do the instruction check. These NOT gates, as I said, are responsible for the instruction check. It means that it will tell us whether the instruction is an A instruction or a C type instruction. Moving on, we have to select select the input for the A register, that whether the input should be the ROM instruction and the ALU output. So that's the role comes in. This is the for the and the mux. Okay, the AND gate, which is this. The AND gate here tells us that if the input is a C instruction, and if input is a C instruction, and if the D1 bit, that is the destination bit, is set. So why we are taking the D1? Because the D1 tells the destination of the C instruction to a register, and if these two conditions are checked, then the ALE input is routed to the A register. The mux here checks if whether the condition are matched or not, and if they are not, then the A register receives the ROM instruction. Okay. Now we have an OR gate, and it tells that if the ALU output or the A instruction is being routed or not, is being routed to the A register, and then it set the A register load bit to 1. The It set the A register load bit to 1, which means that it will store whether the value, whichever value it is getting. Moving on, we have a multiplexer. We have 16-bit multiplexer, whose role is to selecting between the register, whose role is to select between the A register and the M register. So here is the selection and output uh, accordingly. In the multiplexer, it is basically checking the instruction register, and if it is set, then the M register is routed to the ALU. The next AND gate, which is this one, and the next AND gate checks the destination bit of that instruction, and it will check the D2 and the C instruction, and accordingly set the D register to write. Okay, so this is the AND gate, and it will set the D register to write. Further, moving on further, we have the main ALU component. We have the ALU chip. Now we have the ALU, where the multiplexer determines whether we get the M register or the A. It also gets the computation bit, which tells it which function to perform. So whether to perform A plus or minus. Accordingly, we'll tell which function should it perform. After which it performs after which it outputs the ZR and the NG bits. So here are the ZR and the NG outputs to the program counter, and the role of these bits are to tell whether the output is equal to 0 or whether it is negative. Next up we have the outputs. So this OR and AND gate represents the output. The OR gate is here. The OR gate is sending the A register value to the address, okay, of the M register. So that determines what register within the memory of the module are being read or written on. The another OR gate, which is the second OR gate, this one, uh, it sends the output to the memory and determines that whether it sends the ALE output to the register which was selected by the previous OR gate, which is this one, the previous OR gate. Now we have the AND gate, whose okay, let me first highlight it. Now we have the AND gate whose role is to check if it's a C instruction, and if that D3 but is and if that D3 bit is set, and after that it outputs the right bit and the memory register. Okay, so I fumbled a lot, so let me repeat it again. The role for this AND gate is to check the C instruction and the D3 bit to what it is set, and after that outputs the right bit in the memory register. So it will output the right uh, in bit in the memory register. Now this chunk is basically representing the program counter. So if we write in I explain it in detail. First we have an AND gate. Okay, so we have the AND gate which checks whether the ALE output is equal to 0, and if the J2 bit, so we have the J1, J2 and J3, if the J which represents the jump, yeah, which is set but sorry is equal, this AND gate checks whether the ALE output is equal to 0, and if the J2 bit is, which is the jump bit, is set to 0, and so eventually this AND gate is responsible for the jump if equal to statement. The next AND gate is for the J1, so this is for the J2, and then we have J1. Okay, J1 is for jump if less than. The next AND gate is for J1 and check the output of the ALU, and if whether it is set to negative or not. Next up we have an OR gate. The OR gate check the ALU output is equal to 0 or negative, and then sets the variable here to 0 or negative. So here we have the 0 negative output. If it is not 0 or out, then we have an NOT gate to flip it up. The NOT gate now flips it to create a positive bit basically. The next AND gate checks for the ALE output that is equal to 0, and it also checks for the J3. So this is for the J3, as well as it checks for the ALE output, and then set the jump if and set the jump if greater than. Okay, this is done because the ALU output is 0 or negative. Then the program should jump if if less than or equal to 0. Okay. In the next OR gate, which is this one, we jump to A if the conditions are met, which are the jump if equal to and jump if less than. Okay. In the next AND gate, we are again checking for the C instruction and whether the jump is set to A or not. And we have the PC load. At last, the program counter is set to the default increment. Thank you.